Okay, this is section 2.3, day 2, and we are going to talk about synthetic division today, which is another way to divide polynomials. We're going to divide the first one by long division again, just to refresh, and then we're going to do the exact same problem down below, and we're going to divide it using synthetic, so you can kind of see how synthetic division works. So I'm going to put my x minus 3 on the outside. Got 2x cubed minus 6x squared plus 2x minus 7. So first thing, I'm trying to make my x go into 2x cubed. So what will it take for that x to turn into a 2x cubed? It would take 2x squared. So putting that above the squareds, remember we want to keep our powers in straight columns, so I want squareds above squareds. So this is now 2x cubed, just multiplying out front, minus 6x squared. Draw my line and switch the signs. These end up canceling, which is okay. So I'll just drop my 2x down. Now I'm doing x into 2x. So what does it take for x to become a 2x? It would just need a 2. And then I'm going to put that above the 7 because I want to keep my numbers in the same column as well. So I'm stacking powers on top of powers and then numbers on top of numbers as well. Keeping everything kind of organized so you don't accidentally add together like terms that don't belong. So now I've got 2 times x, which is 2x, and then 2 times negative 3, which is negative 6. Actually, I can fix that a little better. Drawing my line means I can drop my 7 as well, since I'm going to be putting it together with the 6. I'm going to switch my signs, and looks like the 2x's cancel, and I'm left with 1 for my remainder. So I've got 2x squared plus 2, and then my remainder is a 1 over x minus 3. So now we're going to do this using synthetic division. See how the process is cut just a little bit short. It goes a little bit faster, but the key is that you have to know that synthetic division only works if your divisor is like this. So you cannot be dividing by anything x squared. Some of the problems you did in the previous lesson had x squared in them, or they were a little more convoluted type of division problem. So synthetic division, the shortcut only works when your divisor is a really simple x and a number, and that's it. So all of these would suffice for synthetic division. So when you set up synthetic division, you have to look at the thing you're dividing by, set it equal to 0, and solve, because you actually need to know your 0, not your factor. So although it looks like this would be negative 3, if you actually solved, your 0 is 3. And that's the number we're going to put in the corner. We kind of put it in a corner box so we know what we are dividing by. Then you're dividing into this entire polynomial. And we're just going to take the coefficients of every term. So the coefficient of the x cubed is a 2, x squared is a negative 6, x is a 2, and then you've got a 7. And this is that place where in the previous lesson I was talking about you need to use placeholders when you are using division, because there are times when if you don't have a power, you have to have a placeholder in its spot. And in synthetic division, that's really key, because if you miss a spot, the whole problem will actually go wrong for you. So if you were missing a power, like we are in the next problem that we'll do here in a minute, you have to make sure to put a placeholder in. In synthetic division, the first thing you're going to do is just drop your 2, or your first number, just drop it down. Then the number that's in the corner, you're actually going to multiply by the number down below. So what's going to happen is you're going to do 2, and you're going to times by 3 and get 6. And then you're going to add down. And then you're going to times by 3 again. And then you're going to add down. And then you're going to times by 3 again. And then you're going to add down. And so by doing this process, what you're coming up with are actually all the coefficients. Sorry, I'm scrolling a little bit. You're coming up with all the coefficients of your answer. Your last column is always your remainder. Oops, and I messed that up here. My apologies. Negative 7 plus 6 is negative 1. I was just wondering why that wasn't going to work. So down here, we just have to figure out how to make this answer look like a legitimate answer, not just a string of numbers, 2, 0, 2, and negative 1. So in our original problem, we were doing an x cubed. And anytime you divide, you're getting smaller. If I take a bunch of cookies and I divide them among people, we're getting smaller groups of cookies. So division has to result in a smaller answer, so a smaller power. If we started off with x cubed, we are now going to be x squared, and then x, and then no x's, and then the last number is our remainder. So we actually end up with 2x squared plus 2 and then the negative 1 over x minus 3, which is the exact same thing. I'm not going to be able to get them both on screen, but the exact same thing is up here. So by long division or synthetic, we ended up with the same answer. And again, synthetic only works if you have a nice divisor. So you have to have this nice, just an x and a number, and that's all you get to have. So doing the next one, again, this is our factor, which means that our 0 is negative 3. So that's the number that's going to go in the corner. The problem with this one is you're missing an x cubed power. You have an x to the 4th, an x squared, and x, and you're missing the cubed. So when you put down your coefficients, the 1, the negative 10, the negative 2, and the 4, you need to put, if this is to the 4th power, where the 3rd power would go, you need to have a 0. And then negative 10, and then negative 2, and then 4. So dropping that first number down, multiplying to get back up, adding to go down, multiplying to get back up, adding to go down, multiplying to get back up, adding to go down, multiplying to get back up, and adding to go down. The last number is always your remainder. And we started off with a 4th power, so our answer will be a 1x cubed, 1 less, and then squared, and then x, and then no x, and then our remainder. So synthetic can make your job a little bit easier, but again, it only works for those certain cases of divisors. You can't use it for everything, and you can't use it when we get to doing i's, imaginary numbers. So long division is still something you need to know, but synthetic can come in handy when you need it. Our last one says, use synthetic division to show that 2 is a solution, that's another word for 0, of this polynomial equation, and use the result to completely factor the polynomial. So what they want us to do is provide 3 factors. We know what one of them is going to be. If 2 is the 0, then x minus 2 is one of the factors. And my job is to find the other 2. I don't know about you, but I'm not very good at factoring cubes. So what we can do is essentially take this guy out of the polynomial. Let's just divide it out and find out what's left. If this polynomial right here is made up of these 3 factors, and we already know one of them, I'm going to kind of just take that out of that function. So 2 is my solution, 2 is my 0, that's what goes in the corner. And my coefficients are 1, I don't have an x squared, that's my x, and then that's my number. Drawing my line, drop down the first number, multiply to get back up, add to go down, multiply to get back up, add to go down, and multiply to go back up. So here's something interesting when we get in there where I end up with no remainder. Anytime that you find out something is a solution, that means no remainder. That means it goes in perfectly because it's one of these beautiful factors. So we're not just straight up dividing now, we're talking about factors of a function. And we started off with an x cubed, so this will be x squared plus 2x and then minus 3. And now that is the thing that we are attempting to factor. You could use the quadratic formula program, that would be just fine. This isn't that bad of a factor, so I'm just going to do it. 3 and 1, and then a plus and a minus. So these are my overall factors of this polynomial. No remainders for any of them. If you were to take x plus 3 and divide it out of that function, you would also not get a remainder. Anytime you have a 0 or a solution or an x-intercept, those are divided in and they are perfect. There are no remainders. So these are my factors, and then if the problem had said give me all the zeros, you would have written 2, negative 3, and 1. So again, synthetic division, it's a good shortcut. It's a good handy tool to have. It can't help you all of the time. Sometimes you have to do long division. And for those times that you can use it,